Right. Good evening, everyone. Happy Tuesday night. Welcome to the Leitner Observatory and Planetarium Tuesday night live stream, which I've been doing some Tuesday nights instead of our usual Tuesday night public night open house, which I miss so much. I miss having people come to the observatory and showing planetarium shows and talking about space, getting great questions from people, looking through telescopes at planets and nebulae and double stars and occasionally a satellite or two, occasionally an asteroid or two. So hope everyone is doing well. It's clear tonight up here at the observatory. It was a beautiful day today. I was here working all day and had several productive meetings about the observatory and I got several things done at the observatory outside, which was nice. And since it's going to be clear, I'm going to be doing some miscellaneous observing tonight after we do this public live stream session. So I am going to try to keep an eye on the YouTube live chat. So if anyone has questions for me about astronomy or what's up in the sky or what we're doing at the Leitner Observatory, anything like that, type your question in the chat and I will try to answer it as soon as I notice it, have a chance to answer it. What I thought I would do tonight is first just talk a little bit about what's up in the sky this week, like I did last week. And then we're going to do some live observing through the 12-inch telescope, which you can see set up here on the observing deck. I've actually got the 12-inch telescope set up and ready to go and pointed at the planet Mars right now. And then I have my star tracker on a tripod, and I'm going to go out a little bit later and put a camera on that tripod and take some pictures of the asteroid Vesta using just my camera. So you don't have to have a telescope to do astronomy. You don't have to have a telescope to do astrophotography. You don't have to have a telescope to track asteroids and comets and planets and the moon. So I've been doing this experiment to see if I can see some of the bright main belt asteroids and track them just using a digital SLR camera. So that's been fun as well. So let me show you the sky chart for tonight, and let's see what's up tonight, and then we'll look at the sky simulator and maybe point at some interesting nebulae and star clusters with the 12-inch telescope. So I usually like to show this evening sky map for the given month. I like this because it's free, it's kept up to date, if you print it out, it's one piece of paper front and back, and it's just really handy for getting a feel of what's up in the sky and where the planets are and so forth. One thing that this map doesn't show you is where the moon is. So you have to actually look at the sky calendar to get a sense of where the moon should be if you're using this to find things in the sky. So today is March 9th. So we have tomorrow morning moon near Saturn in the morning sky, and the moon near Jupiter in the morning sky. Actually, it would be interesting to look at that in the sky simulator in Stellarium, the Planetarium program, and see what that looks like and see if it would be visible from New Haven. Maybe I'll think about, it's supposed to be clear tomorrow morning, I think so. Yeah, I'll clear all night tonight and relatively mild, although by tomorrow morning it'll be below freezing again, maybe. Maybe I'll get up early and go out and take some pictures of Jupiter and Saturn and the moon in the morning sky. But then we have a new moon on March 13th. So that's in 4 days. So we're just 4 days shy of a new moon. That means the phase of the moon now would be waning crescent, and you would look for it in the morning sky. So we're not going to see the moon in the sky tonight in the evening. So what is up in the sky? Well, we've got Mars over here in the constellation of Taurus. I think last week when we looked at it, it was kind of near the Pleiades star cluster. Uranus is a little bit further around to the west from that. And just again, briefly, the way that you use this star map. And I just noticed there's a instruction on how to do this written all the way around the edge of this outer circle, which I had never noticed before. But the way that you treat this is the center of the sky right there where the plus sign is. And so if you say lie down on the ground with your feet pointing south and your head pointing north and your right arm pointing west and your left arm pointing east, then would be your view of the sky if you kind of squeezed it into a fisheye view over your head. Or what you can do is hold the piece of paper so that south is upright and you face south, and turn the paper counterclockwise for 90 degrees, and you see the stars that will be over in the east, like the constellation of Boötes and the bright star Arcturus, and then up a little from that, the Big Dipper over there. We must be getting into spring if the Big Dipper is up in the evening sky, because it's been down in the trees for us here at the Leitner Observatory for the last few months. And then if you were to hold the paper upside down, and you'd see the orientation of the stars in the northern sky. Not much over there, but it's a good way to sort of get the orientation of Polaris, the North Star, and the Big Dipper. Or vice versa. If you recognize Polaris, the North Star in the sky, that can orient you to north. And then hold this piece of paper so that west is upright, and that would show you the stars over here in this direction. So we're kind of in middle March now, so this is kind of what the sky looks like around 8:30 or so in the evening. And the bright stars really stand out, of course, when we have light pollution like we do here in the city of New Haven. You really can only see the bright stars unless you're using binoculars, something like that. So it's good to start with Orion and Sirius over here in the south-southwest sky. So the 3 belt stars in Orion are easy to find. The 3 stars at the 3 stars of the belt point down to the left to Sirius, the brightest star in the sky. And then you can draw a big circle of bright stars around the constellation of Orion. So we go Sirius up to Procyon, the brightest star in Canis Minor, the little dog. Then up to Pollux and Castor, the 2 bright stars in Gemini, the twins. And then up to Capella, the goat star, the brightest star in Auriga, the charioteer. Down to Aldebaran, the bright star in the face of Taurus, the bull. Down to Rigel, the bright blue star at the foot of Orion. And then back to Sirius, and we call that the winter hexagon. Actually, you can use the belt stars of Orion to also help you find Taurus and the Pleiades. So if you see a little cluster of stars or some pattern of stars, and you're not sure if it's the Pleiades, or you want to make sure you're finding the Pleiades, right, the Seven Sisters cluster, you can take the 3 stars in the belt of Orion, and instead of going down to the left, go up to the right, and they will point sort of vaguely in the direction of Pleiades. It kind of helps if you bend towards Aldebaran, and then you'll see the Pleiades a little bit further on. And right now, actually, we have Mars kind of between Aldebaran and the Pleiades. I'll show you where it is here in just a minute. Let's see if there are any other constellations that I want to point out. Cassiopeia, which we saw in the summer, is getting low in the northwest. So I think it's behind a tree for us. Likewise, Andromeda and Perseus. So probably losing those constellations for the season. Really, I'm focusing on the winter constellations of Orion, Monoceros, which is the unicorn. Not a bright constellation, but it's right here in the plane of the Milky Way. And there's a lot of interesting star clusters and nebulae and things to look at in the direction of Monoceros. And also the what I think of as the early spring constellations of Cancer, Leo, and then Virgo. And in about a month or so, we'll be in so-called galaxy season, when it's a great time to look for these bright galaxies in the Leo-Virgo cluster in the early evening from the northern hemisphere. Okay, let me show you where these things are in Stellarium, and we can also take a look at what I'm looking at with the 12-inch telescope. So actually, maybe we'll do that first. I'll just jump over to what the live view from the telescope. So this is a 12-inch reflecting telescope on a robotic mount, and I have connected to the back a video camera. And so I can connect to that video camera via the computer that's out there next to the telescope. So let's see what the telescope is seeing right now. Okay, live view through the telescope. I showed this last week as well. We got a tiny, tiny, tiny little picture, a tiny little shimmery picture of Mars. Mars is looking really small right now and relatively dim compared to the way it looked at opposition. And of course, that's because the Earth is getting further away from Mars. So yeah, that's what it looks like right now. I don't think I can see any surface features it might stabilize after a little while, and I might be able to improve the focus a little bit. And actually, see, I don't know if that will help a little bit with the readout. And no, that makes it just look blurrier. Go back to that. Yeah, I certainly can't see any surface features. It's just a little bit too blurry. I can see that it's not completely illuminated. And this is something I was pointing out last week, is that since Mars is way around on the far side of the solar system, we don't see it fully illuminated. We see it as kind of a gibbous phase, like the moon when it's between, let's say, first quarter and full moon. And of course, we can use that to figure out the angle between the Earth to the Sun to Mars, which we could use to figure out the orbit of Mars if we wanted to. But I can show you what I expect it to look like in the simulator. So here is a zoomed in view of Mars as seen from Stellarium, right? So you can see where we are. There's the sky right now, and make it a little bit less complicated here. There's the sky right now. There's Orion and Sirius, and then you can take the 3 belt stars and go up and to the right and find the Pleiades cluster. So yeah, actually interesting things to look at with binoculars over here in the direction of Taurus. There's the Hyades star cluster, which is here in the face of Taurus the Bull. So an actual star cluster of stars close together in space, all about the same age, all traveling together, orbiting around the center of the Milky Way, just like the sun. And then over to the west from the Hyades is the little Pleiades cluster, the Baby Dipper, the super teeny tiny dipper. And then between Taurus and the Pleiades tonight is the planet Mars. And if I zoom in a lot, because it's really tiny right now, you can see, yeah, there's the phase right there. Boy, if we only could see that detail, that would be amazing. And in fact, I'm seeing the volcanoes. This is the volcanic side of Mars. That's probably, I'm pretty sure that's Olympus Mons right there, the biggest volcano in the solar system on that side of Mars. So no way we're going to get that sharp of a view right now because Mars is so far away. Using the Hubble Space Telescope, or maybe using the most sophisticated adaptive optics ground-based telescope, you could see things that sharp, but certainly not with a small telescope from inside the city are you going to see that much detail. We'll have to wait for the next Mars opposition to see surface features like the dark patches and the volcanoes and the valleys and so forth. I think if we go, get Mars centered here a little bit, if we go a little bit later in time, let's see here, kind of curious, there we go, there's the other side of Mars. There's those 3 big volcanoes. So actually, I think that's Olympus Mons. And this is Reggio, what is it called? Reggio Alpha? I forget the name of that other big volcano that's a little bit around to the west from Olympus Mons. Anyway, let me point out a few things in Stellarium, and then we'll move the telescope over to look at some other interesting targets. I thought last time we looked at the Orion Nebula. Let me actually set time to now. There we go. Last time we looked at the Orion Nebula at the end of the observing session last Tuesday. And I thought we could go back and look at it, but then I thought it also might be interesting to look at this thing called the Horsehead Nebula, which is here near the belt star of Orion. There aren't any other bright planets out tonight, right? There's Mars right there, and the planet Uranus is a little bit further around. There's Uranus right there, a little bit further around the ecliptic. So we looked at that last week. So I think I'd like to go try to take a look at the Orion Nebula, the Horsehead Nebula, maybe some of the star clusters up here in Auriga or in Gemini. And there is actually an interesting planetary nebula over here in Gemini called the Clown Nebula or the Eskimo Nebula. And it'd be interesting to see how much detail we could see in that planetary nebula. So, so as I go around and look at these different objects, let me know if you have any questions or any requests. And I will explain what we're looking at as we go. So why don't we go over to the, seeing if there's anything else I want to mention. Actually, you know what? Before we start taking images tonight, There is one thing that I'll mention, a little bit of astronomy news. Probably most people heard about the flyby of this asteroid called Apophis. And it had its closest approach on Friday, but it wasn't very close to us. There are a lot of other near-Earth asteroids getting closer this month than Apophis. But I thought it was interesting, it was in the news. Apophis is of great interest to astronomers and to some members of the public because we know that it's going to fly by very close on April 13th, 2029. So a little bit about the history of this asteroid. It was discovered in 2004. And when it was first discovered and astronomers projected the orbit of the asteroid, there was concern that it would collide with the Earth on April 13th, 2029. There was quite a bit of uncertainty in the path of the asteroid. And the probability that it might hit the Earth got up to like 1 in 37, I think is how high it got. Now, that's not very high, right? 1 in 37. But still, it would be bad if this asteroid, which is about 1,000 feet across or about 300 meters across, that's actually, now that I think about it, about the same size as the Arecibo radio telescope. So many of you maybe heard that the Arecibo radio telescope, this historic icon, 50-year-old radio telescope in Puerto Rico, had mechanical problems and it collapsed last November. It was very sad. Sad story, but it had a radio dish that was 300 meters across, so about the same size as this asteroid. What's something else that's 1,000 feet across? 3 football fields, a big building, the VAB and the Vehicle Assembly Building at NASA, maybe something like that. Anyway, if it collided with the Earth, it wouldn't cause mass extinction, but it would be bad. You know, it deposit a lot of energy and make a big crater. So we don't want it to hit the Earth, and if it were to hit the Earth, we'd want to know well in advance so we could potentially deflect it, which is certainly something we could try to do. Anyway, after it was discovered in 2004, some astronomers went back and looked at earlier images in the past, found it in previously taken images, and were able to get a better estimate for the orbit and realized it's not going to collide with the Earth on April 13th, 2029, but it's going to get really close, closer than the moon and about the same distance as the geosynchronous satellites, right? So here's an animation of the flyby in 2029. So it flies, it gets close to the Earth. We have a lineup with the Earth about every 7 years or so. So, right, that would be 2004, 2011, 2016, or 2018, right? But, oh, we're up to 2021 now, so I guess it's not quite every 7 years. I think it was discovered after opposition in 2004, so that's why it's throwing me off. But 2021, we have this flyby, which is going to be the closest approach until 2029, but it's not at all close. So I thought it was interesting that I was hearing about this asteroid in the media and people were interested in it. So I did a stream last Friday to try and take pictures of it when it was at closest approach, but a little bit too cloudy, really didn't get any good images. You can go back and look at that stream if you're interested in how it went. So you need a telescope 12 inches in diameter or larger. That's about right. It's not really, really bright because it's not very big. And at this 2021 flyby, it's not really close. It's about, the distance from the Earth to the asteroid was about 11% of the distance from the Earth to the Sun. And it works out to about 10 million miles or so, or about 44 times the distance to the moon. So that's not anywhere close. 2029 is going to get a lot closer. I couldn't see it on Friday night, I tried to look for it on Sunday night, and I did get some nice images of it. So I thought I would show those images of Apophis flying by. So here's a sequence of images that I took with the 16-inch telescope on Sunday night. And if I play these images as a movie, you see lots of stars here in the background, and one of them appears to be moving, and actually it jumps. So do you see that little ant crawling along relative to the background stars? So that is the asteroid Apophis. I've definitely confirmed it. And I took a break in between sets of images of about 10 minutes. So this is its motion over a period of about 30 minutes that I'm showing you here. So it looks just like a star that happens to be moving relative to the background stars. And that's just because it's so small. You can't see any detail in it, right? You're just seeing a speck of reflected sunlight off of this rock that's out there in interplanetary space, 10 million miles from the Earth. And we're seeing a glint of sunlight off of it coming back to the Earth so that we can see it. Now, I've been trying to take pictures of it on clear nights because it's a near-Earth asteroid, potentially hazardous asteroid. It may hit the Earth someday, hundreds or thousands of years from now, not in the near future. It doesn't pose any risk to the Earth. But astronomers would like to know the orbit of the asteroid really, really accurately. So dozens, if not hundreds of astronomers are tracking it this month. And we're going to combine our measurements in a database and use sophisticated computer modeling to track the asteroid and model the orbit. And every measurement that we make is useful in terms of doing this. So later tonight, I'll be taking some more pictures of the asteroid as it flies along. I can try to explain why it's moving the way it is. So if you see the direction that it's moving, it's kind of moving up to the right. If you kind of watch that little point right there. And the reason it appears to be moving that way is that it has an orbit which is tilted relative to the Earth's orbit. And it's going from sort of the southern sky to the northern sky. And then as we fly by, the Earth is moving faster than the asteroid. So it's kind of like when you're running on the inside track and you pass someone on the outside track, it looks like they're going back. It looks like if you look towards them, they're sort of going to your right backwards as you run past them. So as we fly by this asteroid, it's both moving up and to the right because we're going faster around the solar system. The direction the Earth is traveling is off to the left in this image. I know that's kind of complicated. Actually, I have a nice 3D model of the orbit I can show you from the NASA website. So this is NASA JPL's small body browser. This is a great way to get the coordinates and the orbit shapes and the visualization, an image of the orbit of a particular asteroid or comet or whatever. And so you can see there's the orbit of Mercury close in, there's the orbit of Venus right there, and then that blue line is the orbit of the Earth. And you can see over there, there's Earth and there's the asteroid Apophis. So if we focus on the Earth here and zoom in, there you can see kind of where it is today, right? Yeah, there we go. So if we let time pass, you see we're leaving Apophis behind, right? The Earth is kind of going faster in its orbit, so we're passing by. And it's kind of going from further south in the solar system, sort of further north, so it's kind of going higher and higher in our sky as we travel along. But eventually we get far enough away from it that we can't see it anymore, right? Now, it's going to get much closer in April of 2029, and you can actually see there's the point. If I focus on the asteroid, there's the point where it's getting close to the Earth's orbit, right? Right in there, right? You see that white line and that blue line are crossing. And so if the Earth were at that point, it would be much closer to us. And that's going to happen when we're there on April 13th, 2029. So put that on your calendars, April 13th, 2029. We all have computer-based calendars now, right, that go decades into the future. Apophis flyby on April 13th, 2029. And you want to go out with your binoculars and watch this thing. It'll look like a satellite going across the sky, and you can track it with your binoculars. And if you're actually, if you're someplace where the sky is dark, you'll see it with the naked eye going across the sky. Okay, well, now let's go look at some interesting stuff with the telescope. So here we're going to do some live observing with the 12-inch telescope. So let me switch over to the telescope control here. All right, so there's our view, live view of the observatory. And there's Mars still right there. I might need to work on the focus a little bit, so we'll do that when we point at Orion. I'm actually going to disconnect from this program, and I'm going to open my live stacking program here. All right. And we're going to move to the Orion Nebula to start with. All right. Let's see. This is how I control the telescope. So I'm going to say move the telescope, and we'll see it. You can see the video feed outside. We'll see. Oh, there it goes. We'll see the video feed catch up with the telescope moving down there. All right, and see. Well, it's where they are already. All right, so let's see if we've got. Looks like we hit it. There it is. And let me turn on the camera cooling. That will improve the, lower the noise level in the image. And I think 10 seconds is probably fine. I think the focus is okay. Could be better, could be worse. Do a little bit longer exposure and start accumulating here. So, okay, there we go. So now what the camera is going to do is it's going to start taking a 30-second exposure of the nebula, and then another one and combine them, and then another one and combine them. So it's kind of like watching the image get sharper and sharper and less noisy over time. So after we see 2 or 3 of these get added together, so you can see stacked 1, stacked 2, looks really nice, and I can see a little bit of a nebula up here as well. The Great Orion Nebula, closest star-forming region to the Sun, about 15 light years away, with a little cluster of massive, hot, luminous stars down here in the center of the cluster, putting out ultraviolet radiation that's ionizing the hydrogen gas nearby and making it glow. Just like a neon sign. Basically, the same physics as a neon sign. All right, I'm going to adjust the brightness and contrast a little bit just to make it a little bit prettier here. Wow, that's a great looking image for just 3 minutes of work. Let's make it a. What I'm doing basically is trying to subtract the sky brightness. You know, we get some light pollution here in New Haven. You know, we have a light pollution filter which I've used for some long exposures on the other telescope. I wonder if it would be worth trying out on this camera on this telescope, because it would give us a bit better contrast when looking at a nebula like this. Boy, that looks great. The thing that you kind of lose when you're looking at a faint nebula like this is sort of the dynamic range, where you want to be able to see both the bright stars in here and then all of the faint wispy, you know, there's faint a gas emission out here sort of at the edges. All right, so that's 5 images combined, so an effective effectively like a 3-minute exposure. I'll let a few more of those download and combine, and then I'll save the image. Let's see. I'm going to want to save this in a folder for tonight. So I'll just go ahead and make a new folder here. Yeah, this is looking good. How is everyone doing tonight? Been outside to look at the sky lately. Enjoyed looking at the moon. Enjoyed looking at Mars. Enjoyed watching Orion all winter. Okay, I think that's pretty good. That's 8 images, effectively a 4-minute exposure. I'm going to save that and get one more image. Okay. And what I can do is kind of switch between the combined image and a single image. So you can sort of see how much better that combined image is, right? There's the combined image, there's the single image. Looks like the single image also has some artifacts in it that sort of get averaged out when you combine them. There are calibration, there's ways of calibrating these images. Also, I think it could use a little bit more saturation. There's a bunch of, there are a lot of sort of image processing techniques that one could use to make this image look more aesthetically pleasing, or to bring out particular features. So maybe I'll do a video on that at some point. Let me save this image. Okay, so got that saved. And I'm going to go over to look at the Horsehead Nebula. And actually I want to stay on that for a little while, 5-6 minutes, and get a good image. So this is a star forming region with a dust cloud in front of it here. And I have the same thing with the Horsehead Nebula. So I'm going to clear this, and we're going to command the telescope to move to this area up here near this star right here. This is the bright star Alnitak, right? So we've got Alnitak, Alnilam, and Mentaka are the 3 bright stars in the belt of Orion. Those are Arabic names. So I'm going to move the telescope to IC434. Now this is kind of a fun use of this camera and telescope, because unless you're using a special filter and you've got a really big telescope and you've got really dark skies, you will never see this feature with your eye at the eyepiece. The Orion Nebula looks great through the eyepiece, but this is a very faint nebula. And I hope that we'll get a good enough image that you can see why it's called the Horsehead Nebula. All right, let's see if there's anything I want to change. We should, so 30 seconds should still be okay. Let's take some images. All right, there's the, I'll get rid of that. Okay. Okay, so here's the first image, and I don't see the nebula, but we can confirm that we're pointing in the right place. And if we are, we'll hopefully start to see the nebula before too long. Okay. Going to take a look at the star chart. I have those 2 stars, and that star is out of the frame. Yeah, so those 2 stars and that star, that's what we're looking at there. So the nebula should be sort of in here. This is actually, this is an object that would really benefit from having a good nebula filter on the camera as I'm doing this, because it's going to be a challenging I think I'm starting to see an outline. This is only 2 images so far. Yeah, I'm definitely, okay, I'm definitely seeing it. It's so faint. um, yeah, this is something I should really get a filter for and observe for about 2 hours. And I'm only going to spend about 5 minutes on it here with you, but I don't know if you believe me or not, but I'm starting to see a little bit of a dark area right in here. Maybe what I'll do is I'll cheat a little bit and I'll show you the image in Stellarium and come back in about 3 or 4 minutes after several images have combined and see if you believe me that it's there. So if we look at what it's supposed to look like, zoom in here on Stellarium. So there's the bright star Alnitak, which we're not seeing in this image, by the way. We're kind of zoomed into this part of the sky. We're seeing that star, and we're seeing those two stars right there. And then the Horsehead is this dark nebula. So what's going on is there's a sort of a ridge of ionized hydrogen gas behind the Horse's head, which is being ionized probably by this bright star right next to it. It could also be this star over here, which is Sigma Orionis. There are a couple of different sources of ultraviolet light. To ionize hydrogen gas, you need just a really hot star that's putting out ultraviolet, right? We use ultraviolet to do things like sterilize equipment. In fact, it's in a lot of the air sanitizers that people are installing to kill coronavirus in the air. And we use it to you can buy a SteriPen, which uses ultraviolet light to ionize, well, not ionize, but to sterilize water, kill any bugs that are in the water. So the ultraviolet light from these really bright, hot stars are ionizing the hydrogen gas nearby and making it glow. And there is a little bit of a column of denser molecular gas that's full of dust right here in front of the nebula. And it's dynamic, so it's being pushed around by the stars, and so that's why it's kind of taken this plume shape. Let's see if we see anything like this in the live image from the telescope. Here we go. Let me switch back to the live image. I think it's there, but boy, is it low contrast compared to this light pollution from the sky. So what I really need to do is put a nebula filter on the camera. Can do a little better. There we go. That's probably as good as it gets. I need to put a nebula filter on the camera and observe for about 3 hours to get a lot of light onto the camera. But yes, I could see it. I could see it. Do you believe me? There's the Horse's head right there. There's the background glow of hydrogen alpha emission. This is the molecular cloud ridge over here. And it's not a great image, but I think it's okay for effectively 6 minutes of exposure time. Let's see, what should we go look at next? Maybe a star cluster or maybe a planetary nebula. Let's see. I think maybe we'll go up and take a look at, there's this pretty cluster actually in Canis Major called the Little Beehive cluster. Similar in sort of brightness and size to the Beehive cluster. There's also some really interesting star clusters up here in Auriga. Oh, you know what? There's also the Crab Nebula. That might be an interesting target for us. That's also very faint. I guess I'm in the mood to look at faint objects today, but it might be interesting to try and take a look at the Crab Nebula, which is a supernova remnant. Let's go look at the Crab Nebula, actually. I think that will be fun. So I'm going to command the telescope to go to that. Oh, you know what? I will save my bad image first. I'll save my lousy image. Who knows? Maybe after the session, I'll come back and take some long exposures and see what I can get out of it. But I'm going to stop that, and I'll see the image, and I'll clear it. Okay, and then we're going to move to the Crab Nebula. Okay. Chris says, looking forward to the future videos with some explanation of all these features. I'm happy to answer any questions you have about what we're seeing. Yeah, I don't want to go into a long astrophysics lecture. I don't want to bore people who just want to see interesting things through the telescope. But happy to answer questions. Okay, so I'm going to move the telescope from Orion's belt up to that part of Taurus. Let's go ahead and move the telescope. There it goes. This telescope moves a lot faster than the 16-inch. It's a smaller telescope, so it can move. It can accelerate and move faster. So it always gets to the target faster than I expect. Okay, so we're up there. Let's see if the Crab Nebula is there. One thing I could do is raise the gain. That'll make the image brighter. Okay. Hey, first image shows something. So let's let a couple of images come through here. Okay, all right, there it comes. So just waiting for the exposure bar to fill up here, and then I'll start making some adjustments. We're looking more in the plane of the Milky Way here, so there are a lot more background stars. Okay, so this is a faint object, but it's not nearly as faint as the Horsehead Nebula. And I'm starting to see some features. In fact, I can see a pulsar. So I'll explain that here in a second. So let me zoom in a little bit, and let me adjust the brightness and contrast a little bit. So what we're seeing here is the remains of a star that exploded. A massive star that had the core collapse on it. The outer layers blew away in a giant explosion called a supernova. The star became very bright for maybe a month or so, visible to the naked eye, visible during the daytime for maybe a couple of weeks. And this is the shell of the star expanding out and cooling in the past 1,000 years. So the core of the star collapsed to form a neutron star, this very dense stellar remnant, about the mass of the sun, or a little bit more, maybe 1.5 times the mass of the sun, and about the size of New York. So 1.5 times the mass of the sun squeezed into a diameter of about 10 kilometers. And we can see it because it's sending out pulses of radiation. It does this, let's see, I think it's about 500 times a second approximately that it's pulsing. So we see it basically as a solid star, and it's that star right there. That's the neutron star at the center of the supernova explosion. You can also see it in radio waves. You can see it in X-rays. It's a very strong pulsar that's emitting lots of different wavelengths of light. Most older pulsars, you only really see them in radio waves. So they're studied with radio telescopes. Let's see if I can adjust the image a little, make it look a little bit better. That looks pretty good. Now this is equivalent of about 3 minutes of exposure time. And again, this is really not an object that you would be able to see. Need to sort of adjust the white balance a little bit, but yeah, that's fine. But that's fine for now. The focus is okay. It could be a little better, but it's okay. The stars are not super sharp tonight, so it might be as good as it gets. Yeah, it looks really good. If you look at the color of the supernova remnant, you can see sort of the inner part of the nebula is kind of glowing white, or it's kind of whitish blue, if you look at some photos. And that's the very hot gas that's inside the expanding shell. And then you can see these filaments, which are glowing kind of reddish. So you can see there's kind of a red filament there, and a red filament there, and a red filament there. Those are hydrogen, ionized hydrogen filaments that have been directed by the magnetic field from the supernova. And they're also expanding outwards and cooling. And you see a lot more red glow in those little filaments. This camera is a single shot color camera, which means that it has built-in color filters that automatically generate a color image. Usually with these faint astronomical objects, faint celestial objects, what we do is we take images through filters that isolate the colors that we're interested in. So we might spend an hour taking a picture of this nebula with a blue filter, and then another hour with a red filter, and then another hour with a green filter. So since this camera has built-in filters, you don't have to do that, but it does mean that each pixel gets less light. So it does take a little bit longer to get an image. But actually that image is looking quite good, I think. That is the equivalent of a 5-minute exposure, and I think that looks very nice. In fact, I think I'm going to stop there and save that image, and then move on to one more target before stopping for tonight. So let's stop the camera. Look, that looks pretty nice, I think. The Crab Nebula supernova remnant, as seen from the Leitner Observatory tonight on March 9th. And so I'm going to save this. Mayros, hi, is this live? Yes, it's live. Shout out. I'm going to save this image, and we're going to move over to a new target. Okay. So let's go look at a star cluster. Let's go look at that M41 star cluster. All right, so I'm going to move the telescope down there, and we can potentially watch the telescope move. Oh, I'm not connected to my camera. There we go. All right, so there goes clear night, a nice clear night. It's clear on Sunday night, really nice. Got some nice images, and it's going to be clear tonight. And get to do some observing all night. Okay, and let's go see what we're seeing in the camera. Yes, I'm putting out live images from the Leitner Observatory of the Orion Nebula and the Crab Nebula and the little Beehive cluster. All right, I need to clear that. Now this cluster is much brighter than the Crab Nebula, so we'll get a good image quickly. In fact, I think what I'll do here is make a few changes to the camera resolution and exposure time. And now we'll start taking images. There we go, star cluster. Lots of bright blue stars. Get this tuned in a little bit. There, isn't that pretty? Now this would be a lovely target to look at with the eyepiece through the telescope. This would look really great to your eye. It would look much better to your eye looking through the eyepiece than it does here in the static image. You know, these cameras, these modern fancy CMOS cameras are great for pulling out faint objects that you could never see with your eye when you're doing this live electronic assisted astronomy. But these bright star clusters with these just scintillating, colorful little stars in them look really great through the telescope eyepiece. Yeah, and you see here in only 1 minute, we've got a really nice image of the star cluster. It's not quite perfectly centered in the field of view, but that's okay. Now, what's going on here is that this is a group of stars that have relatively recently formed from the interstellar medium, from the gas in the galaxy. Now, not as recently as Orion, right? The Orion Nebula has those really young, maybe they're 1 million years old, which sounds old, but that's actually very young for a star. These stars are maybe 100 million years old. Even that's young for a star. The sun is 4.5 billion years old, essentially 5 billion years old. So these stars formed from the gas in the galaxy. There are different masses and sizes and temperatures. The bluer stars are hotter and more massive. And then those stars that are redder, the fainter redder stars are less massive. And then the brighter redder stars are what we call red giant stars. And these are stars that are already running out of fuel, leaving their normal lifespan phase. And they're going to turn into planetary nebulae in the not too distant future. So yeah, beautiful little star cluster. I love looking at this one through binoculars or through a small telescope. So, and this is a nice image. All right, I'm going to save this image. Actually, maybe we can fit in one more target before we stop for tonight. Maybe we'll try to go look at that planetary nebula in Gemini. So let me save this, and we'll clear the decks here. Okay, and let's see. Can we go get? Find the planetary nebula here. Yeah, let's go see what it looks like. So we'll try to. There goes the telescope. So it's moving kind of up and to the left to point at Gemini. All of these images are coming from this 12-inch reflecting telescope, which is on the observing deck at the Leitner Observatory right now. It looks a little bit distorted because the image is wide. It's kind of wide. It's not that short and squat, although it is a fairly compact telescope. It's a reflecting telescope, so the light goes through the front, down to the bottom, back up to the top, off of a mirror, back down to the bottom, and then it goes into this little camera right here, which we're seeing the live feed from. Okay, so let's see if the planetary nebula is there. Now this is going to be a very small object, but it should be relatively bright. There it is. The Clown Nebula, the Eskimo Nebula. I know Eskimo is not really a word you're supposed to use anymore. It's not culturally appropriate. The people that were called Eskimos properly are called Inuit. So people also call this the Clown Nebula. And the idea is that there's kind of a face there with sort of a furry or a hair around the nebula. What you're seeing here is the collapse of a low mass star. So I showed you a supernova remnant a little bit earlier with the Crab Nebula and the pulsar in the center. So when you have a high mass star that dies, the core collapses to form a, let me just make sure that I'm adding these. Yeah, so we got 5 added there. So the core collapses to form a black hole or a neutron star. The outer layers expand to form a supernova remnant. And eventually that remnant's going to expand and cool and fade, and you won't see it anymore. Although you'll see the pulsar, you can still see the pulsar there in the center. But when a low mass star like the sun reaches the end of its life, the core does collapse, but it doesn't collapse into as dense of a remnant. So instead of getting a black hole or a neutron star, you get this star called a white dwarf, which is something with the mass of the sun but the size of the Earth. So yeah, that's dense, but it's not as dense as a neutron star. So there's a white dwarf right here, which is the core of this star that exploded. The outer layers expand off, but you don't get a supernova. You get sort of just a big shell of gas expanding off of the star and cooling. This object would also look better with a filter, but I think it actually looks pretty good. You see it's got definitely a greenish cast, and that greenish cast is coming from, and try and tune it in here. That greenish cast is coming from ionized oxygen. I think that looks good. So ionized oxygen produces this distinctive kind of cyan, greenish blue color, whereas hydrogen produces a distinctive red color. Oxygen does this. So yeah, that's what we're seeing. I think that's a nice image. Not super sharp, but again, we're looking at it from inside the city. So I think that's pretty good. This is another target that looks good through a telescope with your eye. And I should say it's called a planetary nebula, not because it has anything with planets or the formation of planets. It's called that because when astronomers saw this type of nebula through their telescopes, they saw little bright disks of light, kind of like looking at a planet, like looking at Jupiter or looking at Uranus or Neptune through the telescope, little disk of light. So that's the planetary describes how it looks, not what it's doing in terms of the astrophysics or anything like that. In fact, I have a colleague who calls these stellar corpse nebulas because you're looking at a dead star. You're looking at the core remnant and the outer layers of a star that's died and is returning its enriched gas full of oxygen and carbon and nitrogen back to the gas in the Milky Way to form new stars and planets someday in the future. The Milky Way recycles all of its stars, and someday in the future, those atoms ejected by that dead star will make new stars and new planets and maybe even new life. Who knows? The carbon, nitrogen, and oxygen atoms that are in your body were made in stars like this long before the sun and the solar system formed. So we are truly made of stardust, the remains of dead stars. Okay, well, I'm going to save that image. I think it looks pretty good. And I have to sign off right now and go do something else. And I may well, and I'm going to go take a look at Apophis tonight, take some more research images on that asteroid. And maybe I'll go try to take a few more images of the Horsehead Nebula, maybe with a filter, see if I can get a better view. But thanks to everyone who tuned in for the live stream tonight. If anyone has any questions for me, my email is michael.faison@yale.edu. I'll type that in the YouTube live chat. So feel free to email me with questions. And if you'd like to keep up with what's going on at the Leitner Observatory, we have a website, which is leitnerobservatory.yale.edu. So you can go to that website and You can go to that website and find out what's going on at the observatory. Main thing that we're doing are these YouTube live streams. Next week, we'll have actually a guest speaker. So one of the Yale astronomy graduate, senior Yale astronomy grad students will be coming to talk about his research on using machine learning to learn about supermassive black holes in other galaxies. So that's Richard Gosch who's going to come and do a little Q&A with us about black holes. So bring all of your black hole questions to the Tuesday night live stream next week. And until then, I'll see you next time. Thanks, everyone. Clear skies. Have a great weekend.